Hello, hello, Shagat the Known here. Welcome to another Rust coding stream here on the 7th of December 2022. Local time 1814. Now, I don't want to waste a lot of time, so let's go ahead and get started here. Little recap since it's been a bit. Last time we did the cellular automata map generation algorithm, and perfect, we got it on the first launch here. Get a quick look at what it actually kind of generates here. And today we're going to be doing something called the Drunkard's Walk, which is really interesting. And you know what? I hear something outside. That might actually be a package. Give me a moment. If I hear them knock at the door, I'm expecting something. And of course it would happen right as I start. Yeah, give me just a moment. They're knocking at the door. Perfect timing. Alrighty, sorry about that. It's one of those that said expected delivery like 13:30 to 15:30, and then it got delayed and delayed. And of course, it starts right when it gets here right when I start. Okay, um, so we did the cellular automata last time. We're going to do the Drunkard's Walk this time. I also noticed there were a couple unused things there, and it was bugging me. So we took care of that. So let's get over to the browser now and actually get started. So, Drunkard's Walk map. I'm going to try and make this one go smoothly. So, like the scaffolding here, it's the same thing we've been doing before, so I'll just copy this at this point. Again, I don't really suggest copying new code, but this isn't really new code, right? It's the same thing we've been doing, except it has a different name. It's got all the same basic starter functions. The build function here, however, we're going to, dive into that. That's where it's going to be different. Okay. So it says, ever wonder what would happen if an Umber Hulk or other tunneling creature got really drunk and went on a dungeon carving bender? The Drunkard's Walk algorithm answers the question, or more precisely, what would happen if a whole bunch of monsters had far too much to drink? As crazy as it sounds, this is a good way to make organic dungeons. All right, so I don't know what an Umber Hulk is, to be honest. That's a reference to something, I guess. I just don't know it. So yeah, like I said, we're going to start with the initial scaffolding here, and hopefully this goes fairly well. I'm going to get to this build function here, just to get kind of all that going, because the new is not really anything special. Snapshot, we've been doing that. Spawn entities, it's going to be similar to what we've done in the cellular automata one with the noise areas, it looks like. We'll take another look at that to be sure, but let me expand that a little bit. That should be easier to see as well. Yeah, so we have the noise areas here on the cellular automata, which is the same thing we're looking at on the Drunkard's Walk. So let's go ahead and get started with that scaffolding. And the tutorial text says, as usual, we'll start with scaffolding from the previous map tutorials. We've done it enough that it should be old hat by now. So in map builders, we're going to say drunkard.rs. And that is our file we're going to be using here. And, whoops, wrong character. And basically we're going to close off that build function and close off the impl block. That way it's not yelling at me. I'm probably going to remove this clippy map entry, and I may do some of this my own way, which I kind of like more. I think I know why that's there. We'll see when it happens, though. But yeah, that saves a lot of time instead of having to do that ourselves. Now, one thing that's not mentioned is we need to go include it in the map module in mod.rs. We need to go I mean, it's going to be in, yeah, we just do it here. So it'll be, Drunkard walk builder. Why is that not happy? Let me try it a slightly different way. Oh, it's not, it's because it's not down here. Duh. I was wondering why it wasn't completing, but it did complete the Drunkard's walk builder when I started typing it. The IDE is like reading ahead. It knows, but the file doesn't know, and it's funky. Okay. So we got the basic stuff here, nothing special. We refactored the way that we're spawning things last time to take in an area, and then that allowed us to use noise to, basically with the cellular automata algorithm, we don't have an exact room structure, if you will, that we can use. So we pick random noise, like noisy areas within the map using some kind of a noise function. So we're going to be doing that again here. And everything else is pretty much the same as we've been doing. We can get the map, we can get the starting position, get the history, the snapshot history so we can replay it. We can build it, which is what we're going to be doing here, is really focusing on the self.build and see where it goes. Spawning entities, pretty straightforward. We just take all the areas in the noise areas and spawn in that region, which is again the refactor that we did. And then taking the snapshot. If required, we fill out the history with a current snapshot of the map. Clone the map, basically. All right, so that's about it. And then making a new one is pretty straightforward. You know, initialize with zeros and news and all that easy stuff, right? Okay, so let's get to the build function now, where all the meat of the algorithm is actually going to be. We're going to need a random number generator. And we're going to set a central starting point. Position x self.map width over 2. And the height over 2 as well. And we're not going to do anything else special with that. We're going to do self starting position X and Y for the start index here, which we're setting up. We're just creating it with the XY index function from the map. We've been using that plenty. It should be familiar if you're this far along. Find all the tiles we can reach from the starting point. Now, yeah, I'm a little interested in how some of this is going to happen, because we haven't really initialized anything yet. So, I guess, no, we'll see. We'll see where it's going to go. All right, let map start vec u size equal vec start index. Okay, I see what's going on now. So we're adding our current starting index to a vector of starting tiles, it seems. And we're going to make a Dijkstra map. And I got to see the rest of this. I got to scroll over on my side. So what I remember from this is we basically give it potentially more than one starting location, which is why this is a vector. And then it can actually do these shortest paths for each of those starting points. But because we're only giving it one starting point, we're only going to get it for that one starting point. But we did look at the Dijkstra map last time in the cellular automata. And we're just defaulting the exit tile to 0. And then we're going to be updating that as we go through. Enumerate through all the tiles, pretty straightforward. And if the tile is a floor, we'll get the distance. And then this here, if the tile is too far away, we can't reach it, then we'll make it a wall. Otherwise, else, if it's further away than our current exit candidate, we'll just move the exit. If distance to start is greater than exit tile, exit tile dot 0 is the new index, and exit tile dot 1, which is the float in the tuple, is going to be our actual distance. And we can take a snapshot after all that. Okay, so we're not done yet, but, well, we'll go ahead and fill in the next piece because it's simple. Place the stairs. And that's going to be using our exit candidate, right? So self.map.tiles. We're going to use exit tile 0 because that's the index. And we'll make it a downstairs. And then we'll take another snapshot. We'll build a noise map. There's a lot of similarities going on, but I didn't want to copy this because, well, it's also different. And there are some questions I already have that we're going to have to get into here in a bit. Also, what does it mean I'm not using the map? Oh, it's because I hadn't saved in a bit. It just hadn't updated. Okay. Good. I should update that. I think that I should be able to have it check on its own. All right, sorry about that distraction. So we're gonna make this noise map. It's gonna be fast noise. It's gonna be seated. We're gonna do RNG roll dice, and it's gonna be a 1D 65536, aka a 16-bit number. We're gonna cast it to a 64 because that's what it's expecting. And then noise.set noise type RLTK noise type cellular. We'll set frequency to 0.08. And again, these are numbers that you probably just mess around with and figure out over time. I will do the cellular distance function. Manhattan. Okay, so far so good. Now we have one last little bit here, and then we'll break down what's going on, and I'll express my biggest question at the moment. Although I already hinted at it. It's a little bit more to go. Now this is something I'm going to be changing in a moment. We're going to do it their way. Clippy may complain because they actually have a piece in the tutorial to suppress Clippy complaining about this. But we're going to do it a different way that I kind of prefer. And I think it's good to teach about it as well. Yeah, so Clippy is complaining. We'll fix that in a moment. But this is the entire function for now. This is our build function. And I have a question. So the build function starts out by making a random number generator. Actually, let's scroll up a little bit. Self.build. So when we make a new map, or a new map builder, the map new, recall this does not actually set any tiles to anything other than walls. So I'm a little bit curious at what we're going to do before calling this function, because we seem to be assuming that the map has already changed somewhat before we do build, or we're going to be adding more functionality into this build function, because we make a random number generator, we get the center point as our starting position, and we set that as a start index, and we use that we use that to create the map starts and then build a Dijkstra map out of it. And we basically iterate through to find like the furthest tile away that we can reach to set as our exit tile. And we also set any tile that's too far away to reach to a wall, which I think is interesting because again, everything at this point would be a wall. We haven't done anything to modify the map. So that's interesting. Place the stairs, don't need to explain that. Build a noise map. We did this last time, but basically we seed a noise generator and we set the frequency, the distance function, and then we use that noise generator on all the floor tiles basically to get some noise value for it. And then we can push those values into this map, which our noise areas map. So since we've only done this once before, let's break it down a little bit more. So we loop through every tile, every valid tile, basically, not the borders of the map, right? So we're starting at 1 and we're ending at height or width -1. And if it is a floor tile, we get noise, and then we are multiplying it by this 1024, and I think that's just to make it not an extremely tiny value. I think it gives us a really, really tiny value, and we just want to make it something that's a little more usable. And then we cast that into an I32. And then we're basically saying if the cell value, which is that I32 we just created, if that's in our noise areas, then we're going to push that index. We're going to push the tiles index into that same noise value. So imagine we have a noise value of 1, 2, 3, 4. Each one of those can have multiple indexes on the map, right? That correspond to different tiles that have that same noise value. So we're going to be using that to actually spawn stuff. Now, the thing, again, I've already kind of thrown out my biggest concern or whatever is like, okay, but what are we going to do to modify the map? Because right now it's just walls. So that's something that we're going to kind of keep thinking about. But before that, I did this before. I'm going to do it again. I don't like using this. If it contains the key, get a mutable reference to the key and push something into it. Otherwise, insert the key with this thing. Rather than doing that, I'm going to go with the kind of the hash map API, which I do like more. So it might take me a moment. I'm going to try to do it without looking as much at Clippy though. Self.noiseAreas. Because it's entry. So we get the entry, which is going to be cell value. And then we say .and modify. And we modify it with basically like, what is it that we want to do to it? And it does take a closure. So we're going to say, what is it going to be? V, because it's a vector. And see, now we have the type hint coming in, mute vec usize. And remember, this vector is containing the index. So we're going to say v.push idx. Now, that's all fine, but there's one problem. What if it's not in there? What if we can't modify it? So we have another one that says or insert. And here we'll simply say vec idx. But I think we actually don't want to go with this. I think Clippy's going to complain. We want to go with or insert with. Now the reason we want to do or insert with, and we want to pass it a closure, is because or insert actually has to compute that value every single time. If it's a hard-coded value like a 3 or something, that's not a problem. But the vec macro is having to allocate and create a new vec every single time. So by doing this function, it only calls the function if needed. So if we come into the cellular automata and take a look, I did something very similar somewhere. Here it is, yeah. So noiseAreas.entry and modify or insert with. So basically the same thing that I just did. To me, it is a cleaner way of doing this. And it avoids Clippy being mad. You don't have to suppress Clippy. But it also gets around all the unwraps. There's no need to unwrap anything. And really, in this case, we should be fine unwrapping because we've already determined that it contains the key. It's essentially a redundant check. And it's probably mostly optimized away. It's not a big deal, but I do find this cleaner. It's more like what you're actually doing, right? Get me the entry and modify it or insert. Okay, so now that we've done that, let's figure out what we're going to do next. Looks like we're going to do a refactor in a few moments, which could be interesting. So we've kept a lot of the work from the cellular automata chapter, since it can help us here also. We also go into the map builders mod RS and once again force the random system to pick our new code. And I'm going to be really lazy about that. You don't have to watch me do it. I'm going to just copy paste this over the map thing that we already have. Beautiful. Okay, now let me get back to the browser. Since we're reusing the exact code from Cellular Automata, we should take the common code and put it into Map Builder's Common RS. This saves typing, saves the compiler from repeatedly remaking the same code, increasing your program size. So in Common.rs, we refactor the common code into some functions. In Common.rs, we create a new function, remove unreachable areas, returning most distant. So this is all the Dijkstra map stuff that we've dealt with, and it looks like we're going to have some new stuff going on. Map.populate blocked feels new. Shrink that a little bit. Okay. Map.populate blocked feels new. I don't quite remember doing that. And it looks like we're going to do the Voronoi spawn regions, which we haven't messed with yet. So we'll have to take a look at that as well. So what am I looking at here? 1 second. Okay, good. Something popped up in the background. Alrighty. So we're going to go ahead and do this, which is basically what we just typed. So I may end up just copying most of it, but let's take a look at it. I can copy it from our own code rather than from theirs. But I want to see where we need to start this from. Let's go to the Drunkard and basically is at the map starts. Dijkstra map, exit tile, and then we go through the loop, and then it returns the exit tile. So about all of that is the common stuff. We have to modify it a tiny bit. So it's going to be a public function called remove unreachable areas, returning most distant. Part of me questions if we should. I mean, I guess it doesn't hurt to return the most distant. If you don't want to use it, you can just throw it away. But part of me questions, it feels like doing multiple things at once. Oh my god, the browser is not cooperating. I'm having to scroll it a bit, and it just, like, it is locking up over there. What is going on? Refresh this page. Nothing looks wrong on my end. The page is having a hard time refreshing. Interesting. All right, we'll focus on this for a moment. What was that even called? Map.something blocked. Populate. Oh, we did make populate blocked. All right, what does populate blocked do? If the tile is blocked, then it makes it a wall. Okay. I didn't remember doing that. All right, and then here, I'm having some issues here with the browser. Oh, there it's catching back up. Okay. Searches. I could not read the full comment because it was just locked up in here. Okay. I think we're better now. So we're going to populate blocked. We're going to get the map starts. We're going to make the Dijkstra map. It's not self anymore. It's just map. All right, I think that should be good. Map.tiles, and then it's not exit, it's exit tile. And that's that. That's a pretty easy refactor. Sorry for the little trouble I was having. You couldn't see it, but I needed to scroll a little bit left and right on that, and on the code block, and it was just locked up for some reason. The page was not having a good time. So we're going to make a second function here, and they're allowing Clippy map entry. So we know what I'm going to do. I'm going to fight against that. So I'm going to just copy the signature here and get us started. And let's get rid of that. All right, so we're going to generate a Voronoi spawn region. So it says generates a Voronoi cellular noise map of a region and divides it into spawn regions. So we did talk about this a little bit last time, and it's basically the code that we already did. So I can go over to Drunkards here, and I think we're going to start with noise. Okay, we're creating noise areas, and we're going to return it. So the first thing we really start with is noise, and where does this loop end? Right there. So we're going to go back to common. I'm going to plop this in here. I'm going to say let mute noise areas. It's a hash map with I32 and a vac usize. Okay, now it's going to be a little bit mad because we need to get rid of the self. And then we return noise areas. And hash map is not in here. So we bring it in here. And boom. Did I miss something in the function signature? Oh, I did. Oh, and scrolling broke it again. Interesting. It's going to be this right here. Thank you, autocomplete. I appreciate it. I don't know what's going on today. Weird things are happening. That's all right, though. So now we can generate Voronoi spawn regions, and we can remove unreachable areas, returning most distant. So that cuts most of the work we did. We just typed it all out. We got to copy paste it, and we're going to move some things around a little bit. So we're going to go back over to the build function in Drunkard, and we're basically going to do this here. So find all the tiles is now going to be let exit tile equal remove unreachable areas, returning most distant. It's going to be a mutable reference to self.map. And we can just feed it the start index just like that. And we take a snapshot. Much easier, much, much cleaner. And then this, well, it's probably, without even looking at the tutorial again, I guess it's going to be self.noise areas equal, and then what do we call it? Generate, yeah. And it's going to be and self.map, and we'll pass it the mutable reference to the random number generator, and I think that should be all good. Except exit tile is no longer a tuple, it's just the tile that we need. Okay. And there we have it. And yeah, that's correct. Self.noise areas equal generate Voronoi spawn regions and self map and mute RNG. Beautiful. And then in the example, they've done the same thing in cellular automata. So here we can replace all of this and say self.noise areas equal generate Voronoi spawn regions and self map. Amp. We getting amped. And the exit tile, we're going to remove that. And we're going to say let exit tile equal, what do we call it again? Remove unreachable areas, returning most distant. Alrighty, and that should make everything happy. Oh, we no longer need the Dijkstra map, of course, or the map starts, because that's done in the function we just placed there. All right, I think we are good now. Cool. Okay, so back to the Drunkard's Walk now. Let's click back over here, actually. So this is basically the same code we had before, hence it isn't explained here, but wrapped in a function and taking a mutable map reference, so it changes the map you give it and the starting point as parameters. Now, walking drunkards. The basic idea behind the algorithm is simple. We're going to pick a central starting point and convert it to a floor. We count how much of the map is floor space and iterate until we have converted a percentage, we use 50% in the example, of the map to the floors. We'll spawn a drunkard at the starting point, and the drunkard has a lifetime in a position. While the drunkard is still alive, we decrement the drunkard's lifetime. I like to think that they pass out and sleep. Then we roll a 4-sided dice. If we roll a 1, you move them north, roll 2 south, 3 east, and 4 west. And then finally, the tile on which the drunkard landed becomes a floor. Very simple. That's all there really is to it. We keep spawning drunkards until we have sufficient map coverage. Here is an implementation. So I think, are we doing this on the build function? I think we are. I think we're going to do it at the top of the build function. So we set a central starting point, and we do start index, and then we'll set it to floor. So we're going to say self.map.tiles. Start index equal tile type floor. Very simple, very easy. And now, this is where it gets fun. So we're going to get the total tiles because we need to figure out that percentage. We're going to get desired floor tiles. Risk of freezing again, I had to scroll over, but that's all we're doing. So floor tile count. I find it odd that we're checking right now when we haven't really done much with it. I guess we just need our initial starting, but I mean, assuming we come in with an empty map, it should just be 1 because we just set the center to a floor, but it's fine. Okay, so it's just a simple little closure here. This is my kind of Rust programming here. Get the iterator, filter it, and count. That kind of, it's really nice, really readable, more functional type programming, although not strictly functional by a lot of definitions, but it's fine. We're going to get a digger count and active digger count. And while the floor tile count is less than the desired floor tiles, which was just half, basically, so did something is false. Drunk X and drunk Y are the starting position X and Y, and drunk life is 400. So we've already heard the algorithm, so we should expect most of this to be pretty straightforward. The one thing that I guess concerns me a little bit is, are all drunkards spawn? I guess it works. If they live for 400, eventually they'll go across. The map is not that large, so eventually they'll go across all the map if you run enough of them. So I guess it works. I was just saying, if we start them all from the center, it might get a little odd. But no, I think it'll be okay. It'll have a tendency to make the center of the map the emptiest, and it'll get more sparse and weird the further you go out, which could be cool. Okay, so while drunk life, I don't know why I scrolled up to the top there, or started to. I was already on an autocomplete that I needed. So we get the drunk index, self.map.xy index. I'm actually thinking about replacing all the IDX in the code with index. It may seem pedantic, but I do much prefer being more explicit with variable names. It's complaining, don't worry about that. It's going to stop complaining as we get further on. But I much prefer being explicit with variable names and not abbreviating and stuff if we can avoid it. You know, I mean, the argument is essentially that back in the day when you had small terminals and everything, it mattered a lot more. But today we have nice terminals, we have nice autocomplete and everything, and it really can help your code to be more clear by being explicit in your variables. IDX is not that bad, but I don't know, I kind of prefer index. I think a lot of times I end up making slight typos with IDX because I'd rather just type index. But you know, it is what it is. Just I may end up doing that at some point. I've talked about it a couple times. So while the drunk life is still greater than 0, then we're going to we got the index. So we're going to check if self.map.tiles drunk index equals a wall. Did something is now true. We're just saying if there's a wall there, we did something. And then we're going to self.map tiles. Is this not a typo? I think that should be floor. Yeah, the just to show, the tutorial text does have tile type downstairs right here. I don't think we want downstairs as every single tile in the map, so I'm going to call and in fact it's going to be an infinite loop if we do. Oh wait, maybe hold on, maybe there is something to that. They're using downstairs again later in a conditional. We'll leave it for a minute. I was thinking it might just be a simple typo or something, but no, maybe not. So now the drunk is going to stagger and pick a random direction. So it rolls a 1d4. If it's a 1, then we're going to say if drunk x greater than 2, we move. Okay, so all we're doing here is we're making sure that we move in valid ways, meaning we don't want them to be able to go to 0 on an x value. So we're enforcing that only if it's greater than 2, it can be decremented down to 1, but we can't go below 1. And then 3, it's going to be the same thing for y. And then for anything else, which we know is only going to be one option because of the 1d4. But for anything else, right, let that format. It's much larger when you format it this way than the tutorial text, but yeah, it's fine. I don't mind the larger formatting like this. Some people probably do though. All right, so after the match, then drunk life minus equal 1. So now it's done something, or well, maybe it's done something. We're going to check that, but now it's moved around. That's my initial definition of doing something. But no, we actually have the did something variable, and we're going to check that. If it did something, we're going to take a snapshot, and we're going to increment the active digger count. We're going to iterate over the tiles, a mutable iterator over the tiles, that is. And let's see, if star t equals tile type downstairs. We're going to set it to a floor. Now, that's one I'm not 100% sure about. I really hope that's explained, because I'm not sure why we first set to a downstairs and then we iterate over all tiles just to check if it's downstairs and then change it to a floor. That seems very odd to me. Also, I made a mistake there. I was too distracted by the downstairs thinking it was a typo. All right, so we'll keep ignoring that for a minute and hope the tutorial explains it, but we need to change the floor tile count. So we'll just iterate over it just like we did before. Filter for all the floors and then count. And then finally, there is a console log. Oh, come on. I'm a bit lazy right now, so I'm just going to paste that in here because that's a lot. However many dwarves there are gave up their sobriety, of whom blank actually found a wall. Okay. So it's just some information about what actually happened, how many iterations and stuff we had to go through. I'm not 100% sure about the digger count. Oh, no, that's fine, yeah. That's fine, because that's after one of them died. So, I thought it was in the same loop. So we do this until he dies. We increment the number of diggers. I still don't quite understand this. But, there we go. So, take a look at the tutorial. It's going to be at the bottom here because I'm not going to scroll down and spoil it yet. This implementation expands a lot of things and could be much shorter, but for clarity, we've left it large and obvious. We've also made a bunch of things into variables that could be constants. It's easier to read and is designed to be easy to play with values. It also prints a status update to the console showing what happened. So now we can take a look at what it's actually going to look like. Make sure that's saved. We'll do a cargo run release. I mean, I would say that's working pretty well. Ah, that's the okay. I didn't realize that. We're taking 2 snapshots, aren't we? No, well, we're only taking 1, but it's acting as kind of like 2 snapshots. So the first pass, all the new floors are stairs, like we said. And that's what gets snapshotted. So the next time we go through, all those have been turned into floors behind the scenes. And the new digs, the new floors are now the only stairs. So it's just a visual cue to show us what's being dug out each time. So it should, okay. Now the stairs thing makes sense. And we could see the first time there were, well, this time there were 55 diggers and 44 of them were useful. Last time there were 40, 37 of them were useful. Cool. So there we have it. A mostly working implementation already. We're going to probably clean some stuff up. We're only about halfway done, apparently. You can see how theirs looks. So now we're, oh yeah, that's right. We're going to do a lot of extra stuff too. So managing the digger's alcoholism. There's a lot of ways to tweak the Drunkard's Walk algorithm to generate different map types. Since these can produce radically different maps, let's customize the interface to the algorithm to provide a few different ways to run. We'll start by creating a struct to hold the parameter sets. So we're going to do that in the same Drunkard file. So let's see. We'll put it near the top for simplicity. All right, partial EQ, copy clone. All right, so basically we have an enum drunk spawn mode with starting point and random. I'm a little bit curious why we have drunkard settings, which contains nothing but a spawn mode. I don't know why we wouldn't simply use drunk spawn mode. Well, let's try it. So settings. Oh, I see, because it's settings. It's not just spawn mode. So there may be multiple settings, and as we go on down, we may add more things to settings. I was thinking, why do we not just do spawn mode like this and make it a drunk spawn mode? But no, I see, we might do multiple settings. So, settings, drunkard settings. So now our struct contains those. We're going to make some stuff mad down here. In our new function, we're actually going to want to take those settings in. And then put settings down there. We'll also modify the random builder to take settings. I found a way to unfreeze this when it freezes a little bit back in the browser. So that's good. Drunkard settings. Spawn mode. Drunk spawn mode starting point. And we're going to go back to here. So yeah, I mean, I think it's pretty obvious what the difference is going to be. Starting point versus random. I have to, well, my guess, without looking at it yet, is starting position is the center of the map, and I think we're using it. So it's going to be the difference between using starting position or using literally just generating random X's and Y's. So the tutorial text says, varying the drunken rambler's starting point. We alluded to it in the previous section with the creation of drunk spawn mode. We're going to see what happens if we change the way the drunken diggers after the first spawn. So change the random builder to drunk spawn mode random, and then modify build to use it. So we actually do want to change this to random. So by ideally, what we're going to do is not going to change the functionality we just had for starting point. We're only changing it for random now. So where do we want to do this? While floor tile count is less than desired floor tiles. Did something, and then we're going to set drunk X and drunk Y. And they do need to be mutable, so I'm pretty okay with declaring them here and then assigning them separately. Normally I like to do some more funky stuff, but I'm pretty cool with doing that here since they're going to need to be mutable anyway. And I'm going to move drunk life up above. Generally, just a little bit of philosophy that I have on assigning, on like setting up all your variables. Um, in this case, drunk X and drunk Y are going to have a lot of extra boilerplate around them. So this did something in drunk life or very simple variables, so they can kind of go up and be with each other. But if we, although the tutorial does this, the tutorial then has multiple lines with match statements and stuff, and then after that it assigns drunk life. And I find it a little harder to kind of track everything. If we can keep all the simple declarations next to each other, it's very easy to find. And then if we need to have some more complex logic down here, kind of put that near the end or put that on its own somehow. So we're going to match on that, and let's get to fill the match arms because I'm lazy. So starting point is going to be exactly the same as what we've been doing. Drunk X. And Y, just like that. Now this is where it's going to be the fun one, and I think you can pretty much guess what's going to happen. If digger count is 0, so we're going to start the first one at the starting position. And my guess for the reasoning for that is we want to 100% guarantee that the map has openings at the starting position. So after that point, it'll be random, and then we might even have some parts of the map that are completely isolated and can never be reached, and we'll call that, as we've already seen with the rest of the code, with the Dijkstra map and all that. We'll end up calling those sections that can't be reached. But we want to ensure, what if it's possible that like the tiles next to the starting tile were never filled or were never turned into floors? It could happen. It's exceedingly unlikely, but it could happen. We want to avoid that. That would be my guess as to why we're doing it this way. So we're doing -3 on both of these because we are taking into account the borders of the map. Why is it -3 and not -2? Let's see. If the map is 10 wide, then we want to say, oh, I think it's because of the +1. Because we're off by 1. So if the map is 10 wide, then we want to really go 0 to 7. I feel like I'm missing something. We're not going 0. Oh, right. Because we're starting at 1. So we start at 1. But 1 is a valid tile. 1 is a valid tile. 0 is not. Whatever. I'm just going to go with it for now. I think we've seen a couple other things like that around the borders where I thought it was a little strange. Actually, no, let's think about it one more moment. So let's imagine the map is 20 wide. Then 0 and 19 are invalid. So that means we have to go from 1 to 18. This roll would get us from 1 to 17. And then the +1 gets us up to 18. So it's like we really go from 2 to 18. It's like we never really have the option to hit 1, but we can go all the way to yeah, okay. I don't know if that makes sense, but unless I'm reading this wrong, we never have the option to hit 1 on the X and Y, but we can go all the way to the width -1. It's just kind of funky looking at it this way. Unless I'm missing something, by the way. I could always be missing something. And then, yeah, they're doing Drunk Life down here. But that was kind of my point, is you have all that work to do X and Y, and then you have another thing down here. I like it a little more this way. To me, it's more readable. And the tutorial here says, again, I won't spoil it yet, but this is a relatively easy change. If we're in random mode, the starting position is the center of the map for the first digger to ensure that we have some space around the stairs. Exactly. And then a random map location for each subsequent iteration. And we'll take a look on our own at what it looks like. We won't spoil it in the tutorial. I didn't even scroll down there. I mean, I saw the top of it, but I stopped and went back up. All right. Oh yeah, I like this. Oh, do we get... Ah, damn. We had an isolated section at the top, but it got filled in. And it's going to get filled in most of the time. It's pretty exceedingly unlikely that you'll have a completely isolated section that never gets connected, but it is possible. I'd like to see it, but I'm not going to run this too much. I really like this. That's cool. Okay. That's enough of that, though. Let's get back over here. We're making some good progress, and we're getting close to the end here. So, take a look at theirs. This is a much more spread out map, and it looks like we're going to change the settings now. Just, I already see it happening. Much more spread out map, less of a big central area, more like a sprawling cavern. A handy variation. Now we're going to modify how long it takes for the drunkard to pass out. Another parameter to tweak is how long the drunkard stays awake. It can seriously change the character of the resultant map. So we'll add it to the settings. Here it's going to be... Oh, we say lifetime. Some people that know about Rust lifetimes are shuddering. We'll tell the random builder to use a shorter lifespan. What are we going to do? 100. And we'll modify the build code to use it. Oh, whoops. Bad, I forgot to... switch back to VS Code, but I mean, you didn't really miss anything. I think it's pretty basic what I did. I mean, it was on the screen as well. We got a little bit of a spoiler too. I didn't notice it until until I was doing that. But where were we at? I was trying to show the tidy bits that were different. Yeah. So we added it here in mod.rs. We added the drunken lifetime. We added it to the settings. It's an I32, and then we need to add the build to use it. So what are we going to do? Let mute drunk life. Where is it at? There it is. So we'll just pull that in right there, and that's it. I don't know why. I was lost because I was looking at something else in the tutorial and it threw me off. My bad. It was an easy change, but I was focusing in on something and it just, like, you do that hyper focus thing. So there I was seeing the... All right, just to explain it. I was seeing the box new for this because I was looking at the wrong line and I was like, what in the world are we boxing up? Think. It's a simple change. You don't need to read how to do that one. Anyway, that's a simple change and drastically alters the nature of the resulting map. Each digger can only go 1/4 the distance of the previous one's stronger beer. So they tend to carve out... I'm sorry, I was misreading that. I was thinking it was updating as we go through. No. So each digger can only go 1/4 of the distance of the previous ones we were using, and we could pretend it's stronger beer. So they tend to carve out less of the map. That's going to lead to more iterations. And since they start randomly, you tend to see more distinct map areas forming and hope they join up. If they don't, they'll be culled, just like I already said. And I wanted to actually see that, so it's cool that we're going to get to now, hopefully. We'll run it a few times and see what we get. I think we might get maybe lucky. Nope. Nope. Actually, there's still 2 disjoint sections of the map. Yeah, we just called half of the map. Wow. That's fine. That's what randomness is all about. You get very different very different results at times. This one's pretty cool. Most of the map is joined. Little bottom right parts are not joined. There we go. Cool. All right, enough of that. What do we have next? Oh, we're almost done. Awesome. Oh, we're gonna do one more settings, I bet. Changing the desired fill percentage, I bet it's more settings. Lastly, we'll play with how much of the map we want to cover with floors. The lower the number, the more walls and less open areas you generate. We'll once again modify Drunkard settings. I won't forget this time. So we're going to do F32 for floor percent. And then we got to go to the mod here and set that. And what are we going to go with? 0.4. So a little bit less than what we've been doing. We'll go back to drunkard.rs here. We'll change a line in the builder. We're gonna have to change it like twice. Oh no, we have to change it once. I was thinking of a different line. Desired floor tiles. Floor percent times total tiles as F32 as U size. Very simple. We previously had it just being divided by 2, so that's 50%. Now we're doing the 40%. And nothing else really needs to be changed. That's all we need for that. Let's take a look at it in action. It should be noticeably different, but also not that different, right? I'm going to modify it a little bit and make it much larger. See, we're still taking up a pretty considerable chunk. Oh, that was an interesting one. I didn't realize that never got added to anything. That was a goofy one. And their short lifetimes combined with the lower percentage really did that one in, didn't it? Yeah, we're noticing quite a bit of a different size, actually. A lot more than I expected. So we can go to like 0.8 here. And it's going to be like almost the entire thing. It's going to be a big open area, probably. But I want to see it. Yeah, even despite that, it's actually a lot less open than I expected. We're not done yet, but it still looks pretty cool. Because we get the little walls and little bits and pieces still in the center. But yeah, it is pretty wide open, though. I mean, as we should have expected. There we go. Notice how much longer that took. It's not that it necessarily took longer to generate. I mean, it did take longer to generate. It took more steps, right? 142 dwarves gave up their sobriety, of whom 137 actually found a wall. So 137 iterations that time. But honestly, those iterations are blazingly fast. I just realized I didn't mean to do the Rust meme, but no, they really are. That's going to be like virtually not noticeable to the human. The thing that's taken a long time is the way we're displaying it, right? It just adds extra time so we can see the steps. It really didn't take very long to generate, and if you wanted to do that, you could. You wouldn't have to worry about it. Okay. So we have even fewer areas forming. Yep, we're good. Building some preset constructors. Now that we've got these parameters to play with, let's make a few more constructors to remove the need for the caller in mod.rs to know about algorithm details. Okay. So we're going to Drunkard. I keep forgetting what file I'm going to, so I just search around a little bit. So we have new, which is pretty standard, okay. And then we're gonna do a few here. I am going to be pretty lazy about it. I could just copy it from the tutorial. Honestly, it's pretty simple stuff. It's literally just, you know, different ways of fine-tuning it. So we don't need settings because we're manually building those ourselves. Spawn mode is going to be starting point. Lifetime is going to be 400, 0.5 on the floor percent. Literally everything else is the same. So we have open areas, then we have open halls, and we have winding passages. It could be cool to maybe do the noise algorithm a bit too. Add some settings to it. So open halls is 400 and 0.5. Is there any difference? Open area and open halls are the same. Oh, no, they're not. This is random, yeah. Open halls is random. Open area is starting point. Winding passages is random. And 100 and 0.4, which is what we just saw tested. Okay. We'll modify the random builder. And I am not going to type that right now. It's just adding more matches. We go up to 7 now because it's randomly picking from each of the 3 Drunkard's Walk. Is it open areas? Did I misspell something? I did. It's open area from their code, but I said open areas. Okay. And there we have it. We run it again. See, there's a pretty good likelihood that we'll get one of those, given that it's multiple different ways to do it. We did not in this case, though. We got cellular automata, which is cool. Again, huh? It's like I did save. Wow. Isn't that funny? There we are. That looks like the Winding Passages variant. Cool. Alrighty. A fun fact, the cellular automata algorithm function here. So, well, let's wrap up and then I'll give this fun little anecdote because we're done. I want to wrap up properly instead of going off on a tangent. And then I'll give a little anecdote. So, wrap up. And we're done with drunken map building, words I never expected to type. It's a very flexible algorithm and can be used to make a lot of different map types. It also combines well with other algorithms, as we'll see in future chapters. Cool. Alrighty. So, next up is, we're not doing it today, but it's going to be maze/labyrinth generation. Now, I normally avoid the spoilers in the mid-tutorial. Tome 4? Tales of Majayal or something else? Interesting. I normally avoid spoilers in the middle of the tutorials, but I don't mind giving a little bit of a teaser as to what's going to come in the next section. Started C++ code with pointers everywhere. Took a bit of time to port. Ooh, that's going to be fun. So I want to see what this is going to look like, and then we'll kind of forget about it. Oh, it did say mazes. That's pretty cool. I like it. I like it. I'm ready to do it. No, we're not going to do it today, but this was a fun one. I actually really liked this. I thought it sounded cool, and after doing it, yeah, it is cool. I like this algorithm a lot. So we're going to deactivate. We're going to pop over here for a minute. And we're going to take a look at the cellular automata algorithm here. So just a fun little anecdote. So I've been a big fan of AI for a long time. What actually originally brought me to computer science was AI. Arbitrarily, I'll say it that way. I didn't really know that I was going to like computer science or anything, but I'd always been interested in computers, and I thought AI sounded interesting. So around the time I was finishing up my philosophy degree, and then people were like, you got to get a job with that degree. And I was like, I don't know what I'm going to do. I'll just get another degree. I said, I'll get a PhD in computer science and study, focus on artificial intelligence. Never done any computer science before, but somehow I decided that was a good idea. And so I've always been interested in AI. I've always followed a lot of the AI developments. And my green screen's not up, so you see some weird colors going on. Just ignore it. I've always followed AI developments. I've been really interested in a lot of the last couple of years with like GPT really taking off and just getting crazy good. Image generation, of course, with DALL-E 2. Oh my goodness, I wrote a program and I can't remember the name of the other one. It starts with an S, doesn't it? I feel bad. I feel bad. It's like right on the tip of my tongue too. I wrote a program using it, and I can't remember the name right now. I wrote a little program in a Rust to basically call the Python code and stuff, and let me generate images and all that. I just can't remember the name. Give me one moment, because I actually have I can look at my folder where the projects are at. No, I don't even see it yet, but I remember it's Stable Diffusion. What did I call it though? I can't find it. Yeah, I called it Stable Diffusion Rust. That's it. It really bothered me that I couldn't remember the name. But I like to follow things like that. And hearing about the last week, I think it was a week ago today, the Chat GPT pops up. Now, I'll say this. I've been using OpenAI Playground, which, with like GPT-3, I've been using that for months. And I've been using it for coding stuff. If I, have no idea about something, I'll throw it in there. And it's not perfect, but I've been very impressed with what it can do. And a lot of times I have a lot of fun giving it random pieces of code with no context and saying, what does this code do? And it is so smart. Like, so I would give it, one example is I would give it some code where it's, I did something where I needed to go through directories, and I needed to recursively go through directories. So basically, I don't have anywhere in the code that's like recursive or anything, but it's a where it says like comment, recursively go through direct. I don't have anything like that, but it's literally just like a recursive function that calls itself on subdirectories and applies some stuff to the files and all that, right? So I would just feed it this function, and it was smart enough, like it would even describe it like this function goes through a directory and its subdirectories recursively. Like it'll like describe it in such great words. And this was OpenAI Playground GPT-3. This was not Chat GPT. And I've always been impressed with that. And again, I'll just feed it random bits of code with no context and be like, what does this do? Explain this. And I think it's great. Like, I really enjoy it. And then there are times where it's like, regular expressions, especially at work with all these like nasty Perl things and stuff that I hate. It's like, I don't even want to try to figure that out. Tell me what it does. And it's so accurate. It's so awesome. I love it. So about a week ago, ChatGPT comes out. And now it's like everybody else has caught on to what I've been doing for months with the OpenAI Playground. Now, ChatGPT, I will say, is a nicer interface, and you could really do most of it with the Playground, but you had to fine tune all the settings, and it was a little bit harder to get an ongoing dialogue. You could, though. You could get an ongoing dialogue, but the biggest thing about ChatGPT is it's not afraid to be verbose and give you a lengthy response, whereas the just regular, like in the Playground, it really didn't like to give very lengthy responses if it could avoid it. It was very terse, and it was very hard to have a good dialogue with it because of that. So it's now, like in the past week though, ChatGPT drops, and it's like everybody has discovered what I've been doing and just been like blown away. Like for months I've been sending people screenshots of like, yo, I sent it this code, and I wrote this code to be as confusing as possible, and look, it figured it out. That's crazy. And now I'm seeing like all these people online doing similar stuff with regular expressions, or just like write some code that does this. I love making it do that. You know, I've been doing this for months as well. Like write Rust code that downloads a file with, you know, from a given URL, and I'm like, yep, that's correct. Like it's cool stuff. And I've been doing weird. I haven't done this with ChatGPT yet, but one of the ones I used to do in the Playground is like, write Rust code that generates 7 random polynomials of varying degrees and takes the third derivative of all of them, and or no, even more, like takes the third derivative of every other one and prints them out before and after the derivative. Like weird, goofy stuff like that, and it'll generate basically working code with one caveat. The training data is a couple years old, and the API of the Rand crate has changed. So I had to go back through the different versions of the Rand crate to find one that actually fit the API that that GPT was giving me. But it was like working code that would generate polynomials and do all the goofy stuff with it. Again, just to try to give it the weirdest prompt I could. And you know, I'd even do things like, and between printing each derivative, print the word potato 6 times, like goofy stuff like that. And it would do it. And sometimes you get mixed results, and you rerun it, and then you get better results. So it's not always perfect, but and that's still the same with ChatGPT. But the ChatGPT just all around feels better to use. It is better to use. But my point was, I've been sending people this stuff for months. Like, dude, I told it to do this goofy stuff, and it did it. And look how crazy it is. Or look, it figured out this code without any context, and this and that. So a lot of fun, right? Now, this is a big tangent, a big setup. Too much of a setup, honestly. So let's get back to the cellular automata. ChatGPT launches, and I'm seeing people posting this stuff all over, like Facebook and a little bit on Twitter and all that. More people are getting into this. And I'm seeing some amusing ones. And the first one that gave me the idea was someone said, it was a picture of a chat with ChatGPT, and they said, provide a detailed analysis of the worst case runtime of what function? I don't remember what it was now. The word bubble sort. The worst case runtime of a bubble sort algorithm, but do it in the style of like a 40s, you know, mafia gangster or whatever, like a 40s fast talking gangster. That's what it was, and it does it. ChatGPT is like, now look here, see, this is the bubble sort algorithm, yeah. It's actually giving you the response in that type of dialogue. And I thought it was one of the best things I've ever seen. And I've never tried that with Playground. I still haven't, because I've been using ChatGPT since it dropped. Also, one moment, I gotta sneeze bad. See? Alrighty. So, as I was saying, that's why I kind of trailed off and was like, it's great. Stop, I gotta sneeze. No, so it actually responds in that way, and it gives a full analysis. I think it even gave like code examples. And it's kind of funny because it's using the proper idioms and stuff that you would expect someone in that like dialect to be saying. It was really cool. And that gave me ideas. So I went in and started giving it code, and you know, that's basically the first one I tried. Was I gave it the same prompt, and then I started giving it some of my code, or I was like, explain binary space partitioning in the style of a fast talking gangster or whatever, right? But then I stumbled on the one that I really enjoyed, and that is explain in the style of H.P. Lovecraft. That's been the one that I really like. And, of course, my name Shoggoth is in my name, and that's a reference to Lovecraft. And he has a certain way of writing, and there's all kinds of stereotypes with the way that he writes, and kind of amusing. I think they call it purple prose or whatever. So we're gonna just take a moment to appreciate one of these that I got a kick out of with the cellular automata algorithm, and it is the basically the entire build function. I think I removed I did remove all the comments though. So basically the entire build function here, I might have stopped before doing the starting position and stuff though, because I didn't think it was relevant, but I did give it like this entire build function for the most part in the cellular automata here. It's a pretty lengthy prompt to give it, but all I said was, let me find, I have saved it. Yeah, no, I'm looking at it. And it does, yeah, it stops after setting all the new tiles and stuff. It doesn't do the stairs, and it doesn't actually make the stairs and all that. But I just said, explain the following code in the style of H.P. Lovecraft. And I did it a couple of times because you get different results. And I really enjoyed the kind of results we get. So let's see which one I like more. I think the second one. So it says, the code is a dark and ancient ritual summoning forth powers beyond human understanding. It begins by invoking a eldritch force known as the random number generator, binding it to its will and using its power to twist and warp the very fabric of reality. With the power of the random number generator at its disposal, the code proceeds to reshape the world to its liking. It creates a map, filling it with strange and twisted patterns, and then uses the ancient art of cellular automata to twist and contort the map into ever more bizarre and twisted shapes. The code is relentless in its pursuit of perfection, iterating over the map again and again, each time reshaping it according to its own twisted desires. And as the ritual nears its end, the map is transformed into a twisted, otherworldly landscape, a reflection of the code's dark and malevolent mind. Beware the power of this code, for it is a force to be feared. It is the embodiment of chaos and madness, and should be approached with caution. We'll read the other one just for fun. It's the same piece of code, but you can just hit try again and get multiple iterations, different generations of ChatGPT text. The code is a dark and malevolent spell, summoning forth ancient forces of chaos and destruction. It begins by summoning forth the dark power of randomness, binding it to its will with the ancient incantation of the random number generator. With the power of randomness at its disposal, the code proceeds to warp and twist the very fabric of reality, creating a world of shifting walls and floors. It creates a realm of pure entropy where nothing is certain and all is in flux. But the code does not stop there. It summons forth even more ancient and terrible powers, binding them to its will with the eldritch incantation of cellular automata. With these powers at its command, the code begins to mold and shape the world, creating complex patterns of destruction and decay. The code revels in its power, taking great delight in the chaos and destruction it has unleashed upon the world. And as it continues to work its dark magic, the world around it falls further and further into madness and despair. Beware the power of the code, for it is a force to be feared. I had another one that... I don't have the code pulled up at the moment, but I have another one where I'm not going to do much more of this, but it is fun. I have some code where there's a game called, I guess now they renamed it to just Zoombinis, but when I was a kid it was called The Logical Journey of the Zoombinis. And there is a puzzle in the game. Basically, Zoombinis are creatures made up of like 4 different body parts. They have feet, nose, eyes, and like hair. And each one of those can be one of 5 things. There's like 5 types of feet, 5 types of noses, and so on. And there is a puzzle where you have seats. And the version of the puzzle I was on, it's 2 rows of 8. So you have 16 Zoombinis, and there's 2 rows of 8. But they're like stacked on top of each other. And a Zumbini, to take a seat, has to have something in common with each of its neighbors. So it's an interesting puzzle, and it can be a little bit difficult to just like look at it and say, oh, that's it, you know, I'll just put that one there and that one there and it works. Because as you go through the different difficulties, they actually start to get even more neighbors with each other, and it makes it even harder to find the right permutations. So I wrote a bit of code that actually solves that because I thought it would be a fun thing to do. It's pretty straightforward. It uses what I think would be called a, let me actually check that name. I think it's called branch and bound. Yeah, it's a branch and bound algorithm, is the way I'm doing it. You could do it with some more graph-based stuff as well, but I'm doing it with a branch and bound based algorithm. So I have my Zumbinis, and I get all permutations. So I do a .iter, and I do .permutations. Actually, I can pull it in here. It's not, no, I don't have it open. I don't have it open, and it's not showing up as one of my recent folders, so I'm going to be lazy. But the algorithm is this. You take your Zumbinis, .iter, .permutations, which is from the iter tools crate. So, and I do permutations of the length of the entire vector of Zumbinis. It's always going to be 16, though. That puzzle when you get to that puzzle, you have to have 16. But what I'm saying is give me all 16 length permutations of the vector of Zumbinis. So Zumbinis.iter.permutations, .enumerate. That's just because I wanted to count how many it took to actually find a valid one. The enumerate's not necessary. And then I filter. And I take the permutation into a validate row. And I validate 0 through 8. And remember, that's not inclusive on the end. So it's just 0. It's actually 0 through 7 inclusive. And that takes the top row and just checks each Zumbini against its neighbors to make sure they all have something in common. Then I do another filter and do it from 8 to 16. So we now validate the bottom row. And then I do a .find. And I take, it's kind of weird, but I go through the top row. Okay. So I do a weird thing. I do a range from 0 to 8 to get the top row, and I do a .all on that range. And using that index from 0 to 8, I get the permutation index and assert, or not assert, but check that it's equal to index plus 8, because that gets me the second row. So I'm basically going through and comparing top to bottom on each row, or like top to bottom across the rows. I don't know if I explained that well, but the gist of the algorithm is get all the permutations, filter out to make sure we only have permutations with the valid top row, then filter to make sure we only have valid bottom rows as well, and then find the first one that actually has matching tops and bottoms as well, right? That way we know it's a valid permutation all across the board. So that's like what you might call a branch and bound algorithm. So if we actually look up what that is, branch and bound algorithm, according to Wikipedia, is an algorithm design paradigm for discrete and combinatorial optimization problems, as well as mathematical optimization. It consists of a systematic enumeration of candidate solutions by means of state space search. Algorithm explores branches of the tree, which represents subsets of the solution set. And the branch is checked against upper and lower estimated bounds and discarded if it cannot produce a better solution. So it's kind of like going along with it. I'm not going to read the whole thing. It's a long page if you care. But the idea is I wrote that code a couple weeks back when I was bored, and I decided to feed just that code. None of the code, none of the setup that like populates the vector or anything, just the Zumbinis, iter, permutations, enumerate, filter, validate top row, validate bottom, filter, validate bottom row, find, compare top to bottom across the row, and boom. And I fed that and I asked, hey, explain that Rust code in the style of H.P. Lovecraft. And we got a couple of good ones. I don't know the best one that I want to go. I have 3 that I saved off, but I like this one. So let's go with this. As I stared at the strange and eldritch code before me, I felt a sense of dread and unease wash over me. The words on the page seemed to writhe and shift as if alive and mocking me. I knew that I was gazing upon something ancient and forbidden, something that should not be disturbed. But I could not turn away. The code spoke of a dark and powerful force, hidden within the depths of the Zumbinis. It called forth the ancient power of permutation, summoning forth unspeakable horrors from beyond time and space. And yet there was a glimmer of hope in the code. It spoke of a way to stop the Zumbinis, to bring an end to their madness. It offered a glimpse of salvation, if only I was brave enough to follow it. But I knew that to do so would be to court disaster, for the code was a trap, a lure to draw me into the depths of madness and oblivion. And yet I could not resist. I began to read, to decipher the secrets of the ancient code, and to unlock the power of the Zumbinis. We'll do the other ones just to get them over, then I'm going to be done. But it's kind of fun, and I just thought it'd be a fun little tangent to wrap up. The code before me is a dark and eldritch ritual, summoning forth a power beyond human understanding. It calls forth the ancient spirits of the Zumbinis, manipulating their very essence in order to reveal a hidden truth. Through the power of permutation, the code twists and contorts the Zumbinis, rearranging their essence until it finds the one true configuration. This configuration is then filtered and validated to ensure that it conforms to the ancient laws of the Zumbinis. Finally, the code reaches its climax, summoning forth the power of the Ancient Ones to reveal the truth that it seeks. With a flash of eldritch light, the code uncovers the secret that has been hidden away for so long, and the world is forever changed. Such is the power of the Rust language and the dark forces that it commands. All right, we'll do one more. The code is a dark incantation, summoning forth an ancient and terrible power. Through the use of arcane algorithms, it conjures forth an eldritch force known as the Zumbinis and binds them to its will. The code then proceeds to enslave the Zumbinis, forcing them to undergo a series of cruel and bizarre experiments. First, it subjects them to the horrors of permutation, twisting and contorting their very being. Then it subjects them to the tortures of validation, ensuring that they conform to its twisted standards. But despite the code's best efforts, the Zumbinis are not easily broken. They resist, fighting back with all their might. And yet, in the end, the code prevails. It finds the one Zumbini that meets its twisted criteria and exults in its victory. For the code is not just a simple set of instructions. It is a malevolent force bent on the destruction of all that is good and pure. And now, with the Zumbinis under its control, it can unleash its full power upon the world. Beware the power of the Rust Code, for it is a force to be feared. And there we have it. Again, I just thought it would be fun to talk about some of this stuff. I think I have a couple others. I had it do a Hello World in the style of H.P. Lovecraft. Just a Rust Hello World, FN main, printline Hello World. That's it. The code is a dark and ancient ritual, summoning forth the power of the universe itself and using it to utter a single terrible phrase. It begins by calling forth the eldritch forces of the print line function, binding them to its will and using their power to speak the words, "Hello World," into the void. With the power of the print line function at its disposal, the code proceeds to unleash its terrible power upon the world. It speaks the words with a voice that echoes across the cosmos, a voice that is both ancient and powerful. And as the words leave the code's lips, the universe itself trembles with fear. For the code is not just a simple set of instructions, it is a being of unimaginable power, a being that can bend the very fabric of reality to its will. And with its dark and terrible words, it can unleash chaos and destruction upon the world. Beware the power of this code, for it is a force to be feared. It is the embodiment of chaos and madness, and should be approached with caution. And I did a lot of other fun ones, like a hash map. I don't know if I saved that one, though. I have a lookup table one, explaining a lookup table in the style of H.P. Lovecraft. Explaining the process of making a sandwich. I did all kinds of funny ones. I enjoy like getting weird and goofy responses from AI. I love it. I even did the Zumbini one a couple more times. I don't think I'm going to necessarily read the... Here's a cool one, though. But there is one permutation... I'm skipping through it. Actually, no, this one's really cool. In the vastness of the digital realm, a ancient and powerful algorithm stirs. The Zumbinis, beings of pure code, are summoned forth to be rearranged and sorted by the unforgiving will of the algorithm. As the Zumbinis are permuted and enumerated, only those that pass the tests of the algorithm are allowed to continue. Those that fail are cast aside, forgotten in the void. But there is one permutation that the algorithm seeks above all others. It is a perfect and symmetrical arrangement, one that will unlock the full power of the algorithm and bring forth a new age of computational dominance. And so the search continues deep into the heart of the code until at last the chosen permutation is found. The algorithm triumphs and the world trembles before its might. Literally just the Zumbini code and explain the following Rust code in the style of H.P. Lovecraft. That's all I gave it. And it gives me these detailed, interesting description. And that was probably the best description I've had from it yet. So just for posterity, because I keep reading about this code and I haven't shown it, this is all I fed it. I simply said, that. Did I even do the colon or I do a period? Doesn't matter, but I did a period. So that's exactly what I fed it. And that's the Zumbini code. It's obviously not going to work in this file because we don't know what Zumbinis is. We don't know what validate row is. So if I save, it's not going to be happy. But very simple code. Not a lot going on here. But it's very interesting to get these descriptions from it. And that was super accurate. They're permuted and enumerated. Only those that pass the test of the algorithm are allowed to continue. Those that fail are cast aside. One permutation seeks above all others. Like, very interesting ways to talk about it. I love doing that kind of stuff. And again, the kinds of results that come out of it are just very impressive. I even like doing things like write some confusing Rust code and you know, one of the cool things you could do with ChatGPT is it gives you a response and you could say, rewrite your previous response in the style of H.P. Lovecraft or whatever, right? All right, I told it, you know, write Rust code to generate a vector of random integers and sort them with even numbers occurring before odd numbers. Choose variable names in the style of H.P. Lovecraft. And so we end up with a vector called dread numbers and we're sorting it. It's goofy. I love it. And dread, and it says in this code, the dread numbers vector is used to store the random integers that are generated. Okay, and skip through a little bit, talking about sorting. And then it says the variable names in this code have been chosen in the style of H.P. Lovecraft, with dread numbers representing the vector of numbers and RNG representing the random number generator. These names reflect the cosmic and forbidden themes often found in Lovecraft's writing and help to create a sense of horror and mystery in the code. So we get goofy stuff like that, and I absolutely love it. I do suggest playing around with it. It's a lot of fun. And I actually, to kind of wrap up, I think it's a good thing to use as a tool to help debug issues. Or if you really don't even know where to start with something, or you're dealing with something that maybe has poor documentation, but maybe there's enough out there, maybe it can help you figure it out. For work, I've been doing that with... it's not Visual Basic, by the way. It's VB Script. That's different. I didn't know that at first, which was a pain. But this VB Script that I have to use at work for something, I hate it. It's not fun. But there's like all kinds of goofy stuff that's going on with like the regular expressions and all there. And it really helped to have something like that to be able to work with and go back and forth. So I do suggest using tools like that. But I've been rebelling long enough. I just thought it'd be fun to talk about those. And seeing the cellular automata code reminded me of that. So I thought I'd give a couple of those descriptions because I think they're funny. And I think it's fun to just see this kind of stuff play out, you know. All right. So with that said, thank you to anyone who showed up, whether you're lurking, chatting, whatever. I appreciate it. If you want to catch these streams or you want to catch any of my other streams, hit that follow button. Keep your notifications on here on I almost said Twitter, here on Twitch. If you're watching this in the future on YouTube or you're interested in going over to YouTube, do all the fun stuff over there too. Like, subscribe, notification bell. You know how it works. Leave a comment. I do read them. I got a good comment earlier where someone said, if you're deciding whether you want to watch this video or not, they linked a timestamp. And I didn't look at the context of what I was saying, but I referenced the Shia LaBeouf, just do it me. They linked right to me saying, just do it. Like, I love it. I love it. So I do read my comments. I do appreciate them. And what else was I going to say? Oh yeah. If you also want to know when I go live, or anything like that, or just see random stuff, Twitter, I do link it here in the chat. I don't know if it's linked on YouTube or not. It might be linked to my YouTube account, but it is Twitter, Shoggoth Unknown. You can't miss it, probably. I do post on there every time I go live, and yeah, that's about it. And then I share lots of foxes and stuff because they're adorable. All right, so until next time, when we do the mazes and stuff, have a good day, have a good night, whatever it is, wherever you're at. Take it easy. Also, Dwarf Fortress Steam came out yesterday, and it was amazing.